everyone, Joanna Wilson here for my OCR A-Level Chemistry Manual. Today we're looking at Section 1 Atoms and Reactions, and we're focusing in on formulas and equations.
Just work, shoots are in.
So the things that we're going to tick off our checklist today are to understand the balanced chemical equations and to ensure correct stoichiometric ratios, to define and determine the empirical formula of a compound, to reproduce the formula of common molecular ions, and to predict the charge of ions containing certain elements. So determination of formula then. So we always use the atomic symbol that we spoke about back in video 1, followed by a subscript version of however many atoms are in that molecule. So subscripts in CH4, for example, indicate that there are 4 hydrogen atoms and 1 carbon atom in that molecule. One thing we need to be able to work out and calculate is what we call the empirical formula. Now, the empirical formula is the simplest whole number ratio of atoms of each element. So C2H6 would have an empirical formula of CH3. The molecular formula, on the other hand, is the number and type of atoms in the molecule. So this is exactly what the molecule is. So an example would be C3H7O. And it has to be in the correct order as well. So as you can see in this example, there's actually 8 H's, but the H7 and the OH are separate from each other, as when we draw that out structurally, the OH lies on the end. So if we have the question, what is the empirical formula of a substance that is 40% carbon, 6.7% hydrogen, and 53.3% oxygen by mass? How do we calculate the empirical formula of that? So first of all, we need to define a basis. So if we have 100 grams of the substance, we know that we have 40 grams of carbon, 6.7 grams of hydrogen, 53.3 grams of oxygen. We then divide by the relative atomic mass, and this is actually calculating how many moles there are of each of the elements, and we'll go on to this in the next video. But if we divide by the relative atomic mass, so 40 divided by 12 is 3.333, 6.7 divided by 1 is 6.7, and 53.3 divided by 16 is also 3.33. So the ratios we have is 1 carbon to 2 hydrogens to 1 oxygen, and that would be the empirical formula. Important thing to note is that the empirical formula is not the molecular formula. This is just the smallest whole ratio number that we've got. Thank you so much for watching this teaser video for the OCR A-Level Chemistry Manual. You can now click the link download to download the full manual. Please check it out now. Keep smashing it, and remember, anything is possible if you just work. Bye!